Mobility has always been more than movement. It has fueled freedom, forged connections, powered commerce, and driven progress throughout history. Moving Minds is a series about the people behind the systems, the visionaries, experts, and builders shaping the future of how we move. These are voices that often remain within specialist circles, yet their decisions quietly shape the systems we all depend on. Our mission is simple: to bring their stories, insights, and experiences to the wider mobility industry, giving stage to the thinking and decisions that will define the future of mobility.
Hi everyone, and welcome to a new episode of Moving Minds. I have a very special guest today, as always, and my guest, his name is Professor Dr. Hans-Joachim Hof. He brings a perspective that is foundational for everything we talk about in mobility, yet often this remains behind the scenes, and that is how systems are understood, researched, and ultimately shaped at their core. Professor Hof is a cybersecurity expert at the University of Ingolstadt, with a focus on distributed systems and the security of complex, connected environments. But his impact goes far beyond academia. That's right. And through initiatives like Charisma Research Center, one of Europe's leading hubs for automotive safety and cybersecurity, he is actively shaping how industry research and policy comes together to address the challenges of modern mobility. His work contributes to a broader European effort to rethink how we design, secure, and validate systems that are no longer isolated products, but part of a continuously connected ecosystem that spans from vehicles, infrastructure, cloud, and increasingly AI-driven components. And what makes his perspective especially valuable for us today is that it operates across time horizons, from educating next generation of engineers to influencing current research to contributing to the long-term resilience of mobility systems across Europe. In a world where complexity is accelerating, his work reminds us that cybersecurity is not just an operational problem, it's a system problem. And I'm really looking forward to exploring how he sees this transformation and what it means for all of us working in mobility today. So warm welcome, Professor Hoff. Welcome to Moving Minds.
Yeah, thanks for having me. It's always a pleasure to do a talk with you. I think we did a fireside talk last time, and now it's our first podcast episode. Looking forward.
That's right. So let's jump right into the question. So, I always ask my guests the origin. So, what was it originally that sparked your interest in cybersecurity and connected systems? And how did your path lead into mobility and automotive specifically?
Actually, it's my parents. So my father brought home an Apple II from work once, and then I wanted to have a computer. So with 6 years old, I got my first C64. And I was very, very interested in cheating in computer games. So this was the first driver to get into cybersecurity. The next one was removing protection of copyright protection, which was perfectly legal in the 80s. And then writing mega trainers, so you had unlimited lives and things like that. From the C64, which was programmed in machine language, I became very interested in the Amiga, of course, Commodore Amiga, and switched to the C language. And I later joined the mailbox scene, which was big in Germany in these days. So that's the beginning of the 90s. And I had my own bulletin board system called Chaos BBS. And it was a platform for hacking. And especially, we ran one of the first Doom tournaments in Germany. So I was also, I think, a pioneer in esports in these days. So I get older and I thought about, you have a great interest in hacking. Could you do something useful with that? And in these days, the University of Karlsruhe was a very famous university for cybersecurity research, especially cryptography. And that's why I chose to work there and to do my bachelor and master thesis there. And I became interested in vehicles in my diploma thesis. I did it in 2002 on vehicle-to-vehicle communication, which was a very interesting use case for the mobile ad hoc networks I was researching. And I did some very basic paper on how to establish cybersecurity in cluster-based systems. After that, I stayed in Karlsruhe, did my PhD there, and established the Internet of Things research group at our institute together with two colleagues. Remember, that's the beginning of the 2000s, so that was quite new in Germany. And with that knowledge, I joined Siemens and again did projects in the automotive domain with Siemens VDO. For example, that was in, I think, 2008. We built a real-world demonstrator for software updates in vehicles. So it's not as rocket science as you think sometimes in the industry. And then I did a very good choice. I decided to marry a mobility enthusiast. So my wife is working for a big OEM. And of course, this also shaped my research. I got a research professorship on automotive cybersecurity at Technische University of Ingolstadt and established there a research group on automotive cybersecurity. And I think we're one of the biggest ones in Germany now. Also, I established a bachelor program and two master programs on cybersecurity. And in all these three programs, I teach embedded security and automotive cybersecurity. Of course, Ingolstadt, the home of the Audi. That's something that drives us.
Wow, that is impressive. And, it goes way beyond this notion of secure by design. I would say it's secure by ground up.
The interesting thing is my fear was always, could I get bored of cybersecurity? And the answer definitely is no. It's still very interesting to be in this domain. And I don't foresee that we won't have enough work in the next 10 years.
Yeah, that's absolutely true, which, this leads perfectly into my next question. So, in your work across research and education, where do you see your personal greater sense of purpose or long-term impact, if you will?
There's one thing I really try to bridge the gap between different domains where you use cybersecurity. I did work in so many application domains, for example, power grid, industry communication, so manufacturing, web applications, Internet of Things, medical security. Siemens is a big company, and I saw that there are always very similar problems, but all the domains tell you you are special. So the medical guys said, "Nah, we can't use traditional IT security because we are very special." And when I did my first public talk as a new research professor, the title was "You are not that special." So I gave some insights, what I have seen in working in different domains, and how you can transfer that knowledge to other domains. And the bad part at this day was that right before my talk, there was another talk by an engineer of one of the big OEMs, and they did everything I told not to do. And that was, at least everybody remembered my name afterwards. So that's a great purpose in my research. And I have the privilege to inspire people with my research. That's also something I want to do. And I've been now a professor for 15 years, and I'm really happy to tell you that some of my students chose a career in cybersecurity, and some of them are really successful. So we have some chief information securities officers in the financial industry, for example, here, and a lot of security engineers in the automotive domain, of course.
Oh, that's great. From your perspective as a professor, what is something about cybersecurity in mobility then that even industry professionals often overlook or sometimes even misunderstand?
Yeah, I think the mobility domain really underestimates how hard it is to maintain cybersecurity over the lifetime of a long-living product like a car. So if I ask my students, what do you think, what do the OEM think the lifetime of a car is? And they tell me 8 years, 10 years. And that's exactly the answer I would get from OEM. But the new regulation UNECE R155 mandates for cybersecurity protection of vehicles over the whole lifetime until there is no vehicle on the street again. That's 30, 40 years. And it's really quite hard to do cybersecurity on this period. I did have some experience on that, for example, with the energy industry. You also need support for 20 years. And I did some support for a military cryptography library, and there we had a contract over 30 years. So It's very hard to do that, and I don't see that the automotive industry is at the moment preparing for that.
So everything is short.
Yeah, for example, the tool chains are not available anymore. You have quite complicated tool chains. You need licenses for these tools. Some may discontinue it, and you need to prepare for that. And that's something I'm not seeing here at the moment. The next thing would be, as a computer scientist, of course, cars are getting too complex. And this complexity with all its implications on cybersecurity is also underestimated. We try to get that right now with the software-defined vehicle, but it's still some way to go here. And then there are some, I call them forgotten systems in a car. Not many consider them to be on the attack surface. For example, the battery management system in electric vehicles. And my research group identified several weaknesses and vulnerabilities, even in the common ISO 15118 standard. So there's a real danger here, and we need also to address that.
Mm-hmm.
So those are 3 insights I probably have because I'm coming from another domain and from computer science, which is all about regulating complexity.
Yeah, you have a different pair of glass. So what do you believe is the most misunderstood challenge, if you will, in securing modern mobility systems today with what you said?
I think it's still the cybersecurity related software updates. It seems to be still rocket science, and the new AI attacker landscape really keeps me worried here. We see a new asymmetry. So attackers get really, really fast using AI, and we are still quite slow as an industry to issue updates and to have regular updates. So it's really a big thing, of course, because we need to consider all the safety mechanisms. But if there's a very fast attacker, we need also to be very fast in defense. And I also see a problem with the tool chain and the integration cascade to handle fast updates. What could help here are virtual environments, digital twins, to have fast tests and to become much faster in certification, for example. Again, a look into other domains could help here, for example, in mobile phone development, where virtualization is heavily used here. And the last thing is crypto agility. We don't see that too much. We must switch to post-quantum cryptography in the near future. We know that. And we need to design systems to be able to do this switch now. And this not only means, we need some fields in our protocols that we can change the algorithm. No, it also needs that we need enough computing power, for example, on our ECUs. For example, the BSI now mandates that you use a traditional signature algorithm together with a post-quantum algorithm, which means you need to execute 2 algorithms, either parallel or serial. And this really poses a lot of challenges in realizing that. And we need to be prepared for that. And it's counterintuitive, it's contradictory to use the last percent of computing when you're designing these systems.
Mm-hmm. Now, it's fair to say that connected mobility or connected vehicles or SDV or AIDV, no matter what is the buzzword that we're using here, is at the end of the day, it's a distributed system, right? You need software, you need application, you need an infrastructure, you need a product, etc. So if we look at the intersection of all of that, software, vehicles, infrastructure, what do you think is the most critical but yet underappreciated driver shaping the industry right now, if there is one?
I already mentioned the toolchain and the integration cadence. Together with AI coding like Claude Code, for example, this will be a real game changer. Given that we find a way to validate the code in virtual environments, this could really speed up the development. And my research group is actively working on that. So we are into generative AI to generate secure automotive code. And it's really a promising approach. Look out for our publications in the near future. The other thing would be to establish a flexible computing platform and suitable hardware abstraction that are lightweight enough to be efficient while be a key challenge to establish the software-defined vehicle. So a lot depends on that. And this also supports the AI-defined vehicle, of course. So when we look into computer science, we see that abstraction is the way we want to go. And that's also what happened, for example, in mobile development.
Absolutely. Yeah. Now, you know that in Moving Minds, we put the guests at the core of our conversation. So we are always keen to learn about the role, and you shared your origins and how you came into cyber and mobility. How has your role as a professor evolved in the recent years? And I'm looking particularly at cybersecurity, AI, and mobility in general. They increasingly converge, and you mentioned a few times AI. So, what do you think is the evolution of your role as a professor, not as an industry?
Yeah. So one of my roles is that we need to provide a broader mindset for our students with technologies from different domains. So a car today has so many technologies in it, and the students need to understand it in depth to do efficient cybersecurity here. So this is the first challenge, I would say, to design study programs that are specific enough that they really understand it in depth, but broad enough to get all the technologies covered that we need here.
Mhm.
Then we see with AI the traditional skills, for example, embedded programming, are being devalued, and students need to be flexible, curious, and learn continuously. Long gone are the times where you learn once and then used what you learned for the rest of your business life. So this is
Mhm.
one of the big challenges here. And as my role as a professor, this means that I'm giving a lot of lectures for people that are already in the industry. So kind of updates to their study programs they used to attend.
Mhm.
And we got a legal framework in Bavaria now that makes that possible, and that's quite interesting. So it's also very beneficial to work with people that are like 10 years into the industry. They have a deep understanding, and then I can share what my view on that, and we get a very good results here.
Mhm. So it's kind of re-educate the industry and stay always curious and focused and vigilant on what's next. I
Yeah,
like that. Like that. When you look at the complexity, and we talked about the system that they are getting broader and more complicated, and you talked about actually a whole host of different technology that find its way in automotive. What type of mindset or principles guides your thinking and how to address this?
Yeah, when you stop to know the system in detail, you need to navigate it skillfully. So that's
Yeah.
one thing. You can do that by AI. That's a really useful tool that helps you to find your way in the system. But some traditional principles to guide yourself could be the interface first mindset. So understand the interaction between the components and just ignore the chaos in the components itself. And that gives you a broader understanding of the system. Then I really like the first principle thinking and system thinking approach, where you think in feedback loops and do not only look for one thing, but a multitude of things that break things. That's also interesting. Also, I tell my students accept that there are unknown unknowns. So do
Hmm.
not design for a specific outcome. Design for a range of probabilities and increase the resilience of the system. So this is one approach how you write systems. So when I was younger, I would tell you that this principle is shit happens and
Hmm.
be
Hmm.
prepared for that.
Hmm.
And also, a very traditional thing in computer science is divide and conquer. It's still a good way to understand complex systems
Hmm. Yeah.
and have an outlook for AI tools. They really help you to get your way into a complex code base.
Yeah. So be curious and have this open mindset that we don't know it all is something that you try to foster in your students' mind. That's
Yeah.
quite of interesting. Not
And
not
even
having just the scientific mindset and say this is a very specific approach, but just to go with a curious open mind.
And even we don't know how the job landscape will look in 5 years. And a typical bachelor program is 3.5 years. So we can give the students some basic abilities. We can teach them how to think and educate them how to think. And also push creativity. That's also one thing that is very important, and curiosity.
Now, when you look at your work and whether it's through the students or research or the collaboration that you have with in the industry, what impact are you personally most proud of?
Yes, since 2011, I put a lot of effort in a systematic approach to cybersecurity. This is why I mandated the widely use of TARAs, which is something somehow new in the automotive industry. And it was new when I started with that in the 2000s. I teach that to all my students in very detail, because one of the most important things for engineers is know which problem you're solving. It focuses the effort you do. It's so simple, and it's not like rocket science to do a TARA, but it really helps you. Also, in my approach to education, I very early stated that hacking is fun, but it does not help so much in securing systems, and that my students need a mindset of securing systems, not a hacker mindset. It's really nice, and you get all the students by hacking, of course, but then you need the switch. You don't want people to break the system, but you want people to be creative and build secure systems. And I'm specifically proud on two things I did in my research. My group defined the standard automotive forensic process in the past, and this is the basic for the now established Innovation Center Vehicle Forensics and Accident Analysis at our university. That's one thing, and it's often cited and used in industry. And the other thing is, 10 years ago, I defined Secure Scrum, an hands-on approach for developing secure software using Scrum. And I still get a lot of questions from industry on this, so on some details of that. So this seems to be still in use. So that's really things I'm proud on. Basically, I'm proud if something I did gets into industry, gets used a lot, and is useful for the people there.
Yeah, I must say I like very much the approach. I think as a defender, not as an attacker. While in the industry we hear a lot, yeah, you need to think like an attacker because this is what you want to protect. But what you're saying is so profound. It's like we are smart as well on the good guy side. So we can define systems which is it really complicated to be bypassed or hacked by the attacker side, vice versa. So that's very interesting approach. Now,
So I
you
designed a lab, a security lab, where the students hack the system, and then in the next step they needed to fix the system. So they needed to go to the source code and find out what's the reason for that and how can I avoid that. And that's the learning I want the people, and I get them with the hacking.
that's like teaching debating, where you have to take both stands, and you need to the ability and the flexibility to understand both sides. I really like that. We talked about AI, Professor Hoff, and how it's reshaping not only automotive, but literally everything. How is it influencing your research, your teaching, and your perspective on cybersecurity and mobility? You touched on a few things, but maybe the influence that it will have going forward.
A simple answer, I challenge myself to use AI everywhere. So for everything I do, I think, could I do it by AI? Is it working with AI? And if not, it could be interesting to make it working with AI. So we started with AI in 2016 already, and the first 6-year program of my research group was to establish a hack bot that can automatically hack vehicles. So a security testing bot, let's call it like that. And we did achieve that. We even used old AI, so not the very modern large language models, but ontologies. And these old AI is also very useful, especially in automotive forensic, because they can show you how they come to their conclusion, in contrast to LLMs that could not do that. And of course, then we adapted to LLMs, and also we research how generative AI can be trained to deliver secure software. And then, of course, you have the attacks on AI. That's still a very very broad and open field. How can we manipulate AI, and especially how can we do that in the field? You probably all know that you can put stickers on signs, traffic signs, and sometimes it will hinder the recognition of the right sign. But does it also work when you're going fast? And it's not only one picture where it works, one image, but you have several images when you're coming near that, and most attacks then break and do not work in reality. And looking into that and look which attacks work and which don't is very interesting. Also looking in systems that are not suspicious to be safety critical. For example, the voice assistant used in modern cars is also very interesting.
Yes.
And then, of course, how can we secure that?
Yeah, absolutely. Yeah, I mean, with all the hype, I guess you would agree that there are some safety critical features in the vehicle which must be deterministic. We cannot leave it to AI.
Yeah, definitely. But you have AI, for example, in sensors that are used for autonomous driving. How do you secure a sensor? That's like also forgotten AI. It's somewhere in the system and probably you don't aware. Of course, you know there's an autopilot running and that uses AI, but also the sensors use AI.
Yeah, but the decision making ultimately happens at a later point in time. The sensor is sensing and the decision making is different. With AI, I would assume that the sense and the decision making are all in once, and that when it breaks. So making it deterministic at the decision level is probably a good thing when it comes to safety.
And we're not still there, to be honest.
We are not there. That's right. If we look now a little bit into the future and the developments in mobility and cybersecurity, I can tell from the excitement that you use in everything you share with us. When you look at the research and innovation perspective, what do you think is up next in your domain, in the academia?
Yeah, the widespread use of AI. So I'm really fascinated what can be done with LLMs, but it's still a long road to secure LLMs. So this specific technology of AI, the large language models, will be used very heavily in vehicles, I think, and that's interesting. And let's see how we can secure that.
Yeah, so that would have been my next question. So it's good and bad in the sense that would you see that this is the biggest unresolved risk or blind spot that we have when it comes to securing future mobility system? Is that the big play?
It's not really a blind spot, so we know that the problem is here, but we don't have a solution for that. So normally we have an engineering solution. We just need to put effort in that. But AI security is very interesting because it still needs a lot of research before we are there.
So it's good that you guys are investing a lot of time and effort to help us in the industry to do that.
You already can see that. Again, look at other domains, how the common chatbots are not secure and how hard it is to make sure that you don't do a prompt injection or do a jailbreak. And this is only a website. So
Absolutely.
it has bad press and that's it. But with a car, you may damage people, and so we need to be extra secure. On the other side, it's very attractive, and the Chinese are doing it, so we also need to do it. There's a huge push that we need that technology in the car.
Yeah, absolutely. Now, we've come to the last question, and as a last question, I always ask my guests if you could give one piece of advice, in your case, to students or even young professionals entering the field of mobility and cybersecurity, what should they focus on to stay relevant and impactful?
Yeah, have a look on your soft skills. So stay curious, learn to think out the box, and then observe what cybersecurity is doing in other domains. So interesting things are happening here. For example, how do you change to post-quantum cryptography? That's one thing that's very interesting. Stay open to learn from what others did, even if you think that you are very special. So that would be my advice.
Okay, I like that very much. So thank you again. And what I'm taking away from this conversation today is that securing the future of mobility doesn't really start with tools or technology. It starts with how we think about systems maybe in different and innovative ways. And the way we design the system, the way we connect them, and ultimately the way we educate the people who build and operate them is really what matters. And your perspective highlights something that's easy to overlook in fast-moving industry, that long-term resilience is shaped just as much in research and education as it is in products and operation. And that the challenge we face in mobility are not isolated problems, but deeply interconnected system questions at the end of the day that require collaboration across industry, academia, policy, as you mentioned. So again, thank you so much for sharing your insight and for the work that you do. I think it's really important, and we are very curious to see where this brings us on your journey, and the thinking that is needed behind bringing those things forward is really exciting. So thank you to you again and everyone who is watching and listening, and thank you again for joining Moving Minds.
Yeah, thanks for inviting me. It was, as always, a very big pleasure to talk to you. And also thank you to Upstream Security, because with your study on cybersecurity in the automotive domain, you're really pointing the finger on the things that are relevant. And that's also very, very important for academia to show that the problems we are talking about are relevant in practice. So thank you for that.
Thank you very much. Have a great day.
If today's conversation offered a new perspective on what drives mobility, we'd love for you to follow the series, share it, and tell us your thoughts. You'll find more episodes with the people shaping what's next. One question, one insight, one decision at a time. Until next time, keep moving forward.